Welcome to our next unit on momentum. Since we're just starting momentum, it's probably significant to ask ourselves, well, what is momentum? So that's the first thing we're going to do. Define momentum and impulse. Second, we're going to explore why we measure momentum. What's the value behind it? What does it actually mean? What does the value tell us? And then thirdly, we're going to be able to calculate momentum and impulse using values so that it's easy to compare the momentum and impulse of different objects. So let's get started. I want to open up with a little thought experiment. My question is, you're standing there in the grass on a sunny day, and all of a sudden, Ryan Pickett from the Green Bay Packers comes along and wants to tackle you. You look at Ryan Pickett, he's got a mass of about 150 kilograms. And he can move at a velocity of about 4 meters per second. And you say, oh no. Then you look to the other side, and at the same time, a greyhound, the fastest dog on earth, with a mass of about 30 kilograms, and able to run a velocity of almost 20 meters per second, also wants to tackle you. Which one will do more damage? Which one would be worse to run into? Well, Ryan Pickett has a greater mass, but the greyhound can have more velocity than Ryan. Which do you prefer? Well, scientists way back thought the same thing and asked the same questions, maybe not about the same scenario, but the same idea. We now call this concept of comparing an object's mass and their velocity momentum, because it's evident that both the mass and the velocity matter in telling us which one of these is going to do more damage in a tackle. So let's just start off by defining momentum. Momentum, which is represented by the letter P, is the product of an object's mass and its velocity. So if we look back at our thought experiment, if I multiply the mass and velocity for Ryan Pickett and the greyhound, I actually find out that both of them will have the same momentum. So both will do the same amount of damage in a tackle. So another way to look at momentum is to call momentum inertia. We've talked about inertia as being a mass in motion. How does mass look, feel when it's moving? And we can also represent momentum by an equation, where P represents the momentum, M is the mass, and V is velocity. Now we can also take a look at units, because we know mass has the units kilograms, and velocity has the units meters per second. So if I combine those two units together to get my momentum, I'm going to get kind of a funky unit. Momentum's units are kilogram meters per second. So let's try an example. First, I want to know which has more momentum. I've got a Mack truck, and it is sitting on the road. So I can assume, since it's sitting there, its velocity is 0 meters per second. Now, I don't know the Mack truck's momentum, but I can assume that since momentum is mass times velocity, and the Mack truck's not moving, its momentum is 0 kilogram meters per second. Well, let's compare that to the momentum of a bullet. We've got a bullet flying with a velocity of 1,200 meters per second. Now, we're not given the bullet's mass either, but we know it's really small compared to a Mack truck. But when I solve for momentum, I'm going to find that since the bullet has a mass and it has a velocity, this momentum is going to be some value greater than 0. Meaning our bullet, even though it's got a tiny mass compared to a Mack truck, is going to have more momentum, because an object without velocity has no momentum. So let's try calculating momentum. What if I wanted to know the momentum of a 0.4 kilogram baseball moving at 30 meters per second? Well, let's just look at what I'm given so far. We've got 0.4 kilograms. That's a mass. And we've got a velocity of 30 meters per second. If I want to find momentum, I can use my momentum equation, P equals mv. Let's put in what we know. 0.4 kilograms times a velocity of 30 meters per second. And I end up getting a momentum of about 12 kilogram meters per second. Let's try one more example. Very similar with the values and what we're looking for. So I want you to try it on your own, see what you can come up with. You can check your work with what I'm doing up here. So we've got a mass of 15 kilograms and a velocity of 12 meters per second. If I write my givens, this is what I come up with. And we'll find out that the object has a momentum of 180 kilograms meters per second. Hopefully you got something similar. So now we've talked about momentum, we've talked about how to calculate it, but what happens when an object changes its momentum? We see this all the time. The catcher catches a baseball and slows a fast speed pitch down to 0 velocity. Or a car coming up to a red light slams the brakes on. Change in momentum, how can we describe that? Well, I'm so glad you asked. This is where impulse comes in. Impulse, which is represented by a J, kind of inconvenient, but J impulse is the change in momentum. So we can write it as an equation like this. J is change in momentum, and you can find this equation right on your reference table. But let's just talk about what we know. We've seen that delta sign, it means change. We've seen it before. Whenever you see that sign, that means you take the final of some value and subtract the initial. So since we're talking about change in momentum, we can actually rewrite this equation as momentum final minus momentum initial, because I'm looking for the change. But we can write it even more than this, because we know that momentum is a mass times a velocity. So let's make this even more specific. To find an impulse, we can take the momentum final, which is a mass times a velocity final, and subtract the momentum initial, the mass, which stays the same, minus the velocity initial. And that will give us our change in momentum, or our impulse. So let's take a look at an example. What is the impulse applied to a 980 kilogram car as it goes from rest to a velocity of 15 meters per second? Remember, rest is our hidden word telling us that velocity is 0. Let's take a look at this. We know that the mass of the car is 980 kilograms, and we know that it goes from an initial velocity of 0 meters per second to a final velocity of 15 meters per second. If we're looking for the impulse, I'm going to write out my impulse equation. J equals change in momentum. Then I'm going to change it so I have change in momentum final minus momentum initial. And let's now make it the mass times V final minus mass times V initial. And we can plug in what we know. The impulse, J, is equal to 980 kilograms times a final velocity of 15 meters per second minus the mass, 980 kilograms, times the initial velocity, which was 0 meters per second. That makes our last term 0. We can multiply the first two together, and we're going to get an impulse of 14,880. Now, if we take a look at the units, momentum that's changing gives us an impulse. So actually, impulse is going to have the same units as momentum, kilogram meters per second. And now we've arrived at our impulse final answer.